There's a group of people at the heart of the British establishment who think the way we've been doing climate science for the last 40 years is wrong. We need to take their concerns seriously because the people who are concerned are actuaries. They're experts in risk and uncertainty. It's their job to make sure their employers, such as the big pension funds or insurance companies, have enough money to cover their liabilities, not just for day-to-day aspects, but to make sure they're able to withstand a financial crisis so serious that it might only happen once every 200 years. I think by the time you've seen this video, you'll agree we should have been doing it the way the actuaries wanted to all along. This video is based on a single report published by the Institute and Faculty of Actuaries, the professional body for actuaries in the United Kingdom, and the University of Exeter, to explain how the approach of actuaries is different to that of climate scientists. I'm going to use this chart. It's quite well known. It's from one of the United Nations climate reports, and it shows what temperature we might expect to get to by the year 2100, depending on how quickly we decarbonise our global economy, or how slowly we decarbonise. So at the moment, with the rate of decarbonisation and government policies, it's thought that by the year 2100, we could expect to have an increase in temperatures by 2.6 degrees Celsius. And that number is in the official United Nations report. Everybody uses it. World governments, the Guardian newspaper, a reliable source of information. I do it on YouTube. I make my YouTube video and say, by the year 2100, we shall be at 2.6 degrees Celsius of warming. If you're an actuary, you don't just take that at face value. You want to know, where has that data come from? Is it reliable? Who put it together? How did they put it together? So an actuary wouldn't be happy just saying we're heading for 2.6 degrees Celsius warming by the year 2100. They would want to see this chart instead. It turns out nobody actually thinks they were heading for 2.6 degrees Celsius of warming by the year 2100. That figure was produced by a project called CMIP6, and that took computer models from all the way around the world. They gave them the same starting scenarios, the same starting data, so as to make their results more consistent. Well, this chart shows the results of all those models. They're the sort of dark brown, yellowy colour, and it shows that the computer models think that by the year 2100 we could be heading for between 2 and 4.5 degrees Celsius of warming, not 2.6. So what the scientists did was they took the average, and the average of the computer models was 3 degrees Celsius of warming by the year 2100. And that was still too high for the scientists because they've got some other climate research, including equilibrium, climate sensitivity, one of the oldest conundrums in the climate science. And that asks the question, if we were to double how much CO2 is in the atmosphere, how much would temperatures increase, including short feedbacks but not long feedbacks? It's still not fully understood, but the scientists think they've got a better understanding of it now, and they thought the models came back with results that were too high. So instead of using the model data by itself, they used what's called an emulator. I don't 100% understand it, but it takes the data, I think, from the models, which are very complex and very expensive to run, and it allows the scientists to add little fudges to it. It has different parameters that they can add in. So for this one, they said you have to limit the amount of warming you can have. So the average went down from 3 degrees Celsius to 2.6 degrees Celsius. Well, if you're an actuary, if you're an expert at dealing with risk and uncertainty, if you're dealing with large amounts of money, the future of your big financial institutions relies on them. This way of coming up with data isn't necessarily the best way, especially because what have the scientists done? They've taken the average. Remember, actuaries, they want to know their businesses are going to be safe against financial risk that might only happen once every 200 years. So actuaries are much more interested in the higher range of results, the ones that are around 4 degrees Celsius. Although having said that, 2 degrees Celsius is just as devastating, well, it's not quite as devastating, but it's devastating enough at that sort of temperature increase. Cities in Europe start to run out of electricity and water at the height of the summer. Agriculture and people in southern Europe have to move north. That's Europe is quite a temperate area. All areas around the tropics, start to become uninhabitable, cities run out of water. So 2 degrees Celsius is serious. 4 degrees Celsius, that really is serious. So the actuaries are much more interested in those higher results, especially because the scientists have discounted them. If you see this green dashed line, that shows that scientists have sort of discounted the lowest 5% and the highest 5% because they think they're unlikely. Well, for an actuary, underestimating risk is very serious, especially if it's in one of the most potentially damaging aspects if you go to near 4 degrees Celsius. So they'd be very interested in those results, whereas the scientists, they're just happy to go for the average. In the insurance sector, risk assessment by actuaries is based in part on understanding scenarios that could have the greatest impact, even if their probability is low. For risk management purposes, an estimated probability that is lower than the real probability is a bigger problem that probabilities are too high. And the average brings us on to another problem with the chart, so there aren't enough problems. The scientists have taken an average because they don't know which of those climate models are better than the others. An actuary, remember, they want to understand where the figures have come from. They would want the scientists to look at each model in turn and understand which aspects of the Earth's climate systems they include or don't include and how they've been included. And then the scientists should take a decision and say, this is the best model, so we're going to rely on these results, possibly. The scientists can't do that because the models are so complex. The only people who really understand them are the people who work on them. So they have to take an average. The actuaries think if there's high levels of uncertainty, then using a computer model is a bad thing to do and it just makes things worse. A rule of thumb for risk modelling is that when uncertainty is high, simple models tend to be more helpful than complicated ones. This is because if the model output depends on assumptions that are used when building it, and those assumptions are uncertain, the model output will tell you more about the assumptions than the real world. So if you have a simple model, you can understand how to produce the results, you can carry out a common sense test. What's interesting is that both actuaries and scientists think that they're being conservative in their work, but it means two completely different things to each profession. For a scientist to be conservative is they only make reports on things which they are sure are rock solid. They need rock solid evidence. If they say things that later turn out to be untrue, then it would damage their careers. Could be the end of their research. But for an actuary doesn't want to be super accurate and doesn't want to wait around for rock solid evidence. They're experts in dealing with risk and uncertainty. Even if something has a low probability, if it would have a high impact if it happened, they're going to take that seriously. Remember, they want to keep their businesses running for the next 200 years, come what may. Actuaries working in risk management are conscious of this and tend to be conservative in making choices when model building and estimating. Conservative to a risk manager means biased high, which can have the opposite meaning in science. But the actuaries save their most damning criticism for the climate models. The status quo of poor understanding of model limitations and assumptions cannot continue. Current climate model limitations and assumptions are not well understood and uncertainties are not communicated well. The consequences of this are serious, particularly when risks are misrepresented or understated. As mathematical models are only an approximation of the real world built on underlying assumptions, the actual probability of some events may be significantly higher than the probability estimated by the model. The actuaries are completely baffled why anyone would think you could model climate change using a computer model and have any confidence in it. With climate modelling, there is limited relevant past data. There is no historical precedent for the rate of increase of greenhouse gases, so we cannot be confident about how quickly the planet will warm, although we can estimate where we might end up with this level of greenhouse gases. Further complexity is introduced because many of these factors are interdependent. For example, a rising physical risk environment may bring increased support for policy shifts, which will accelerate the transition, arguably a phenomenon we are now observing. Ongoing investments into fossil fuel infrastructure will bring increased emissions, which will accelerate warming another current phenomenon. So if we go back to that very first chart we'd looked at, there's no guarantee we're going to carry on that 2.6 degrees Celsius trajectory, if that's where we are heading to. We could do better, we could do worse. It's just completely uncertain. Let's forget how the scientists work for a moment, and instead let's look at how actuaries work. With a climate model, you start off in your current year and you run it year by year into the future, into 100 years into the future. Any assumptions that are wrong or badly implemented mean each year your results get a bit less accurate until 100 years time. Who knows where you're going to end up. And when you get there, you still don't find out what it was you wanted to know. 2.6 degrees Celsius for warming to someone living in cold Britain sounds quite nice. It doesn't really sum up the full horror of where we're going to, and it doesn't tell us what we really want to know. Will there be enough food and water? What will happen to our global economy? What will happen to our modern civilization? Will my pension be okay? Will the value of my house be affected? Will I have enough to eat and drink? Or will civilization come crashing down amongst our ears? So instead of just using your climate model into the future, the actuaries work the other way around. They go to the future, to the year 2100 or possibly the year 2200, because those are the sorts of timescales they're used to working with. And they think about what they call ruin scenarios, the scenarios that would cause the collapse of civilization, would cause the collapse of countries and starvation and all these other terrible things. And they say to themselves, well, what scenario would lead us to getting there? In reverse stress testing, insurance companies ask themselves the question, what would ruin us? And work backwards from insolvency to construct a set of events that may lead to this. When you know it, it seems obvious, doesn't it? Why weren't we doing this from the very beginning? 15 years ago, we were. Sir David King, when he was Britain's climate envoy in the run-up to the Paris 2015 agreement, carried out research together with Chinese and Indian scientists to help them understand where we were heading to and the impacts of climate change. And he did use actuaries then. Why are they not used now? Possibly because we're in such a predicament, can't really even cope with the averages of where we may be heading to. The first thing the actuaries want us to do is to carry out a comprehensive risk report. Apparently, no one has done this in the last 40 years. It sounds like a useful thing to do. Because no one's done it yet, the Count Everything channel will do it, and I will explain to you where we're going to in the future, taking into account the high-risk, low-probability events, because that's what we're interested in. Well, I've been doing videos on this subject for the last 2 or 3 years, and I've sort of covered everything. The collapse of civilization decade by decade, living and dying in a climate apocalypse, looking at the high-risk, low-probability things, because I thought that might encourage people to act on climate change. When you free yourself up from the world of scientists, where everything has to be 100% rock solid, and you allow yourself to imagine scenarios that might lead us to running out of food and water and the end of our civilization and just be unbearably hot, suddenly everything becomes much clearer and much less restrictive. So, for example, collapse of critical Atlantic current is no longer low likelihood. If that Atlantic current stops, Europe becomes colder by 1 degree Celsius a decade, and it becomes much drier, meaning agriculture would probably no longer be possible, and probably wouldn't be enough water for people living in the southeast of Britain. We are perilously close to the point of no return, climate scientists on Amazon rainforest future. The Amazon rainforest and other tropical forests absorb a lot of CO2 each year. They're an important part of keeping our CO2 concentrations in the atmosphere down. Planet's first catastrophic climate tipping point reached. The warm water corals support so many species of fish that 1,000 million people rely on those fish for their livelihood. Glacier meltdown risks food and water supply of 2 billion people. So that's 1,000 million people affected by the warm water corals becoming extinct. 2,000 million being affected by the mountain glaciers becoming extinct. There are 700 million people living in Europe who'd be affected if the Atlantic current stopped. Global heating will push billions outside human climate niche. Well, there's only 7 or 8 billion people living in the planet. So far, with a few articles from The Guardian, like half the world's population is going to be affected. At least. Plus, There's all sorts of tipping points which aren't really included in the United Nations reports because they're just too difficult to predict or to say when they will happen. So, for example, when I did the AMOC video, standing on the beach in Portsmouth, they said then, this is the United Nations report. It has all about the AMOC, but they say in a single sentence, but if the AMOC was to stop completely, which is its tipping point, it stops completely and Europe becomes very difficult to live in, then everything would change. They just cover it, that tipping point, that devastating impact, with a single sentence, because they're scientists. They won't say the AMOC is going to stop, the Atlantic current is going to stop, unless they've got rock solid evidence. But for the actuaries, even though it's low probability, because it's high impact, that's something they're very interested in and would want to include in their scenarios. Planet likely to warm by 4 degrees Celsius by the year 2100. Well, we sort of know that, or it certainly could warm by that much. But the scientists have produced a diagram that shows when the different Earth systems are likely to reach their tipping point, and instead of gradually changing, as many of them are now, they would suddenly transition to a completely new state with devastating impacts. So here's the diagram, and you can see by 4 degrees Celsius of warming, so with our actuary heads on, we could very easily be heading for 4 degrees Celsius warming by the year 2100. Low probability but high risk, so we want to take that into account. And we can see every major Earth system that the scientists are concerned about will have tipped by that time. There would be a sudden transition to a new status with devastating impacts all around the world to the climate, except for Arctic winter sea ice, East Antarctic ice sheet. Everything else tips at 4 degrees Celsius. And even if you're being Mr. Conservative, only relying on the rock-solid science that says we could be heading for at least 2 degrees Celsius by the year 2100, the Greenland ice sheet, West Antarctic ice sheet, warm water corals, permafrost in the northern forests, Barents Sea ice, Labrador Sea, extrapolar alpine glaciers. Those are the mountain glaciers that 2,000 million people rely on. So even at the most conservative estimate, those are all pretty devastating changes that are going to happen. When it comes to reducing our carbon emissions and changing our lifestyles and affecting our economies possibly, the governments do not want to know what the actuaries have to warn them about. They're having enough trouble just keeping up to the averages and not taking into account the low probability, high impact events. But when it comes to what's called adaptation, which is where you change your infrastructure to be able to cope with the new climate that's coming along, governments seem much keen to do that. So in my videos we've done Portsmouth, Britain's first island city to be lost to sea level rise. They're spending, I think, was it like £180 million or £300 million improving the sea defences. According to the scientists, we should expect an increase in sea levels of 0.6 metres by the year 2100. Britain's sea defences and the Thames barrier are being improved so they can cope with a 1 metre increase in sea level rise, although there is a small chance, maybe a 10% chance or 5% chance of 2.3 metres of sea level rise if the the Greenland ice sheet meets its tipping point, which is going to. It's just a case of when rather than if. London is in danger of running out of water. When they ran it through the computer models, they thought maybe the amount of water coming into London would be reduced by 15%. Instead of just adding 15% more water to help offset that, they're going to bring in so much water into London that instead of it being able to cope with a drought that's so serious it might only happen once every 100 years, they're going to provide enough water so that London is able to cope with a drought so severe that it might only happen once every 500 years, or at least in the old climate. They're not sure what the new climate will be, but if they think they bring in so much water, that will protect them. So when it comes to adaptation, protecting your own people, your own country, governments are very keen to take this actuarial approach and be able to cope with low probability, high impact events. They do know what's going on, don't they? They do know there's a proper way to manage these things and to understand what's happening and to protect yourselves, but they're only prepared to use them to protect themselves. They've sort of given up hope of being able to reduce the CO2 emissions significantly enough so we have a survivable future otherwise. At the time of making this video, there's COP30s going on in Brazil. I'm ignoring it because at the moment they're just discussing whether they should put it in their final statement that they want to phase out carbon emissions or even mention carbon emissions at all. Since that's the whole point of the conference, let's not worry so much about reducing emissions anymore. Let's just protect ourselves, although with adaptation, although that will only work for so long. There's only, you can only bring so much water into London. You can only improve Britain's sea defences by so much. 40% of our food's imported. We're building lots of new houses on prime farmland. There's lots more we can do. That's the end of the video. It's not the most exciting subject, but I thought you might be interested to hear about it. I was interested to hear about how actuaries, they go to the end where you want to get to, work backwards. I thought that was an interesting thing. And their damning opinion of the climate models, which I've noticed nobody likes climate models anymore. So that's the end of the video. Feel free to leave a comment and click the like button, and thank you for watching.